Good morning, GMGM. Thank you, everybody here, for choosing to spend your time at our third inaugural NoirCon.
All right.
Cool. Yeah. Thanks for having us here, and thanks for coming to the workshop. Looking forward to looking under the hood of what we built with private FaceMatch. Really excited about it.
Yeah. Just as a kind of like introductory question, who here has used ZKPassport? Oh, that's a fair amount of people then.
Pretty good.
Yeah. So you should have like some rough understanding of how it works, at least from a user perspective.
And for those that haven't, we're going to go over just high level, like what we built and how it works, so you can kind of understand what it's all about. And then after that, we'll go into the details of, I guess, also explaining what private FaceMatch is, how we achieved it, while retaining, like preserving user privacy, and then, yeah, I guess dive into the weeds a bit more and actually unpack the technologies that we used. So, thanks. Cool. So, at a high level, what is ZKPassport? It is government-attested identity. So everyone in this room, your passports, they all have an NFC chip on them. And on that NFC chip contains your personal information embedded there and also signed over by the issuing government, creating an unforgeable tamper-proof seal. This is the key here. And then our circuits essentially verify that signature. There's a chain of trust from the root certificates of the country. And this is maintained by, they're called ICAO. They're like under the UN, and they basically, through diplomatic channels, they will collect all of the different root certificates from the different countries, and they'll put them in a master list, and that's available for everyone to get. And then we have a certificate registry that we maintain, where we basically get all of these different certificates across different master lists. So each country has their own master list, of what they essentially consider to be a valid government root certificate. There's an overlap, mostly. And then we go through, we deduplicate those, and then we Merkelize it, and then we store the root on-chain in the certificate registry. And so what you're proving against with a ZKPassport proof is that it's signed by a valid government. The signatures are valid. There's the root one, there's the intermediate one, and then also the passport data itself. And so this whole chain of trust, the root of trust is that root, essentially, for that Merkle tree. So you're not trusting us at all. Like the provenance of the signature is kept intact through the circuit. So we're just basically providing the circuit for that logic to be verified. And then obviously, because it's ZK, you can also have this like little trick where you make it private, and then now it's like you get the benefit of privacy too, which ultimately means that you can have selective disclosure. So you can selectively choose to reveal certain parts of your passport, and that's what our protocol provides. So when you plug this in as a developer, you can specify what it is that you're asking the user to prove. And you can also have other cool approaches to this where it's like prove that you're from a country or from a set of countries. So for example, Devconnect, they provided ticket discounts if you can prove that you're from LATAM. So we have a Devconnect integration, and hundreds of people use this to come through and get a 50% discount on their ticket without revealing anything else about themselves except they're from LATAM. And so, yeah, this is the flow.
Yeah, this is the interface, and I think all of you are familiar with it. So you scan your passport or ID cards, as that works as well, especially in the EU, with residence permits too. It loads into the app, stored, encrypted locally on your device, never leaves it, and from there you can answer to specific requests from website, such as was the case with Devconnect or was the case with the Aztec token sale. So that's the kind of request that's done is up to the website through our SDK. For example, in case of Aztec token sale, you have sanction checks and private FaceMatch. So you have a good guarantee that's the person on the ID, and some other, such as being over 18 and other details.
So this sanctions check that we do, this is also a really cool ability to prove like full name and country and date of birth now, because we have these credentials to use. And so with the Aztec token sale, what that ZK KYC is doing is, with a sanctions registry that we maintain, a similar approach where we have like a root, We've Merkleized 4 different sanctions lists from like the OFAC SDN and then one from the UK, and you're proving completely privately that you are not on that sanctions list. Which is a really, really cool primitive to be able to do that and not have to provide your personal details to some provider that then checks themselves. It's kind of inverted. It's like, you give me the sanctions list, I'll tell you if I'm not on it, but what I'm saying that is truthful because you're binding that in a ZK circuit. So this is how you'd be able to integrate with us, is with several lines of JavaScript, TypeScript.
Yeah, this is SDK, so how you would essentially communicate with the app. The SDK takes care of everything. The WebSocket connection to the mobile app, end-to-end encrypted, receives back the proof, verifies them for you, including the public inputs, and then you can use those proofs either off-chain or on-chain. You can pass it to your smart contract. We have the smart contract verifier, which has now been deployed on mainnet and also base as well. We're going to deploy on other networks too.
Yeah, we've just deployed a mainnet, which is exciting. So now we can go multi-chain, and we've designed it in a way so that there's this universal address through like the create2 with like a salt. So what that means is there's a single address for the root verifier across all chains, even the ones we haven't deployed to yet. And you have this query builder, as you can see, where you can just like chain on different things to kind of add to what you're asking. So here it's like query builder dot greater than or equal to for the age 18. So this is like 18 plus basically, and you can kind of keep going. There's like for nationalities, for sanctions lists, for anything you can think of, like to reveal that's in any kind of combination of the passport data. And then one feature we'll be adding soon to really help with integrations is like a form where you'll be able to specify exactly what it is that you want your users to be proving, any kind of combination, so like visually through a UI, and then it'll generate the code for you. So like a code generator for Solidity. So then you can just, and TypeScript, so you can plug this part into your front end and then plug this code into your Solidity contract to bind it to your particular service. And one other important concept here is you have this, typically it's called a nullifier, but we call it a unique identifier. It's a bit more kind of user-friendly. And the idea is that for every passport and service, the unique identifier will always be the same. So this prevents like double registrations. This is essentially how you achieve super resistance, but it's scoped to the domain name of the website so that you don't have a global unique identifier that then you could have 2 services comparing, knowing it's the same person. And then you can have a subscope. So perhaps you wanted to do like voting, so you have like a different poll. You can also like scope it again to a particular use case of your service. And this is also the stuff that you'd bind to in the smart contract to ensure that it's actually for your service for a given domain name and like use case. Cool, and then on to the title of the workshop.
Private FaceMatch. So essentially, this is a more recent feature. A lot of there's a bit of there are other identity solutions, ZK ID solution, but the main problem we have is that you can use a bunch of documents that may be or not your own. So you could, let's say, pick up your brother's or your father's or mother's document. So you need a way to prove that you're the person on the ID, and that's what we provided with FaceMatch. So what it does is it will pull out the photo from your ID, compare the camera feed from your phone to that photo using face embedding, compare the cosine similarity, and then also provide a liveness check. So you need essentially to look in specific direction. We look at your gaze, and that prevents essentially trying to spoof the system using, for example, putting your ID in front of the camera. That wouldn't work through the liveness check. So this is all done locally. The models are all stored locally. Some of you may have seen a complaint about the size of the app, I believe. This is one explanation for it.
That's the reason. 170 megabyte.
We have absolutely no connection to whatever services that was, intelligence services that was mentioned. The actual thing is the SRS. So this is the trusted setup for Mastec, 128 megabytes, because the circuits we use are up to the subgroup 2 to the 21st, and about 180 megabytes of models for private FaceMatch. We have a small one for OCR, but it's not that big, and some other artifacts, essentially.
And so, yeah, the real magic here is that you're essentially being able to prove that you are the same person on the document, but never revealing your face to anybody, which I think is like really cool and really magic. This is like really the magic of ZK, the kind of stuff it can do. So everything up to that point is cryptography, is the cryptography part of it. So it's like completely sound and secured. This is using a mobile TE guarantee. So it's still really strong, but it's on, for iPhone especially, I would say like a state level actor would be able to bypass this. But you're not doing it at a lower level. It's kind of like a nice icing on top. And so that's what we're going to explore today is how we actually achieve that through a service called Attestations. And then, we can also do some I guess, coding part of this as well. Yeah. And so there's an equivalent on Android called Play Integrity. And it's a very similar setup. I suppose I can just dive into the explanation now, right?
Yeah.
It's next slide. It's QR code. All right. So the way it works is with Apple iPhone.
Do you want to show the diagram or?
Yeah. I mean, it's a pretty full-on diagram.
Yeah.
But yeah, makes sense.
Yeah, we got some visual help. It's going to be a little bit scary at first. But we can zoom in as we explain.
Well, maybe I can explain it like myself first.
Yeah, we can give a rough explanation and then jump into the details afterwards. It's a slightly different than Android, but the principle is similar.
Yeah, so Attestations for iPhone, the way that it works, let me just bring this up as a nice... Oh.
Yeah, this.
Yeah. So the way it works is so every iPhone on the secure element, or the secure enclave rather, there's a key pair, and that's called the device key. And Apple has the public key for that. So they know about basically like they have this key pair that Apple knows the public key of because they created the device in the factory, right? So they have a link. They know which devices are genuine iPhones. And then during this process of Attestations, there's a new key pair generated on the enclave. And then there's a certificate signing request where essentially that new key pair is it's signed over locally by the key pair that Apple knows about, the device key pair. It's sent to Apple. Apple can see that, yes, this is a genuine iPhone because it's signed by the device key pair. And then they'll use their heuristics to determine whether or not it's jailbroken. So there'll be like thousands of like eFuses on an iPhone. So if you ever try to kind of get into it and tamper with it, they'll permanently blow. They'll use all these other heuristics and checks, things like which version of iOS is it, what's the bootloader version. All these checks basically, and they do a really good kind of best effort job to essentially determine that this is a non-jailbroken, it's an authentic Apple iPhone that's running the correct code. This is essentially trusted computing, which is this for iPhone and then also for Android. And by the way, this can coexist with, I think this is often kind of, it's not really like a dichotomy. I think it's a false dichotomy of having trusted computing and then the alternative of like being able to sideload. Apple should open this up, and I think what would be ideal is a way to have both trusted computing, but also having the ability to sideload. And it just means that you wouldn't get the same guarantees, right? But you'd be able to sideload anything arbitrarily. But then you have no guarantees that it's essentially that it's running under these constraints. And so the constraints that exist. Wait, I'll continue the flow on. Sorry. So you get the signed key pair, the signed payload back from Apple, and then now you have a guarantee that, like at least from this signature from Apple, that the key pair on the secure enclave is on a genuine device. And so then moving forward, you can have the app perform arbitrary logic. So for example, in our case, you did the inference over the camera feed when you're doing the face scan, and it will compare that cosine similarity, which is essentially a value that allows you to compare two vectors. So we get one from the passport photo, one from the face scan. We compare the two. If it's above a threshold, then it passes. And then over a custom data structure that we've got, we save like the embedding value itself, which is the actual face print. And then we save like the cosine similarity that was achieved, like the average, all these different custom values. And then we sign over that data. We get a hash of it, and we sign over that with the key pair. Then we, in our circuits, we'll prove the entire chain back to Apple's root certificate. And this is the chain of trust with private FaceMatch. So for Google, it's Google Play Integrity's root certificate. theirs is a lot more difficult. It has like 5 different.
The actual certificate chain varies from manufacturers, and the signature algorithm are different. So it's a bit more messy than iOS. We needed to generate more circuits. The similar way we did for Passport, where we generated a bunch of combinations, we had to do the same for Android. And it varies. So you can have like 1, 2, 3 intermediate certificates. So that varies a lot in terms of like circuit size. And then you need to add separately the play integrity logic, which is separate from the key attestation. It's not a unified thing like on iOS. And then you have like the custom OS like Graphene, which we do not support yet, that don't use play integrity. We would need, I looked it up, we will support it later. You would need to check specifically the bootloader version. I will need to look at the security guarantee of that, but apparently it's pretty good. So yeah, Android is a bit more messy being an operant system.
Apple's a lot more elegant in their design and simple. It's just a root certificate that it's fixed, always the same, and they have an intermediate certificate that can change, but that's fine because you have the root anyway. And then after the intermediate, that signs directly over the payload of the signing key on the enclave that was generated for this app.
But also what I mean is that on Android, if you root your device, you're not going to be able to use private FaceMatch because we can't check the guarantee of the device.
Yeah, and that's why I think it'd be nice to have designs in the future that allow trusted computing and non-trusted computing to kind of coexist, and then you just don't get the guarantees. I suppose you'd still need to have like rooting, I guess, kind of overrides it at the top level. But if you can almost have I guess there's more involved than that. But then on the OS level, the way that the actual the guarantees are enforced or provided is you have the kernel communicating with the secure enclave, and so an app has it's like a bundle ID that's signed by the publisher of the app, which is us. As a publisher, we're signed by Apple. This is like when you get the Apple account, and so you have this chain of trust where on an Apple iPhone you can only run code that's signed by a publisher. And so when our bundle ID, which identifies our app, will request its own key pair initially, the kernel will forward the message through to the secure enclave, and then it will generate the key pair, but only for that app, only for that bundle ID. So only our app can use this key pair going forward to sign over data. And so with that guarantee, you can essentially sign arbitrary logic now, and you have the guarantee with Attestations that it is from our app, one of the apps that we published, because of all of these checks that take place. So it's kind of like a hybrid almost of like a TE that you get normally, where it's like really like full on with like an Intel TDX and everything is done in that way. But this is also very similar guarantees, but on a consumer edge device, which is exciting because we can now do these unlock these really cool primitives. For example, it would be possible to have as a future ZKPassport feature, you can have proof of, say, like location. So maybe you can get the GPS coordinates in the app, and then now you can prove things over the GPS coordinates, and you have the Attestations guarantee. So maybe you don't want to expose the GPS coordinates directly, but you could, in a ZK circuit, you could do a mapping to like a city, right, or within a radius of a certain location. So many cool use cases for that. Some other ones might be, you could do like proof of IP address. Obviously, it's not foolproof. You could use a VPN, but the idea is that at some point in time, like you had this IP address because the app was able to like essentially have that through contacting some external service, and then maybe you don't reveal that directly, but you have a mapping of IPs to countries, all these other interesting checks that you could apply. I mean, it's kind of endless now because you could even tap into like fitness data. This would be a whole separate like product or protocol, but you could do like proof of like running miles. And I'm pretty sure the Apple Watch has a TE in the same way with a secure enclave. You could use the Attestations for this. Different product, different protocol, but I think you get the idea, right? It's like custom logic running inside an app by publisher, and that's where the guarantee comes from.
Yeah.
I feel like that. Thanks for coming to our workshop. Let's dive in more.
Do you want to show the diagram more in detail?
Yeah. So this is specifically for Apple, where there's just the root certificate. And so this is just kind of like an explanation of the Apple root certificate. all like the relationship all the way through. Their key pair signs with a fixed signature algorithm, which helps us a lot, which signs over this intermediate certificate, which can change, but also is the same algorithm. Signs the message hash of this credential certificate, which embeds the key pair from the secure enclave. Yeah, I mean, I think conceptually I've already probably explained it pretty well. But if you ever wanted to dive into the details more, we'll be publishing like a write-up on pretty much what I've said already, but then also exactly, like precisely how it works, including diagrams and this kind of thing.
And so essentially in Circuit, what it all comes down to is verifying a bunch of hash and signature. So if you use the Noir CDSA library and the Noir RSA, because actually Android, they use RSA on Android. So Google is still using RSA for their root certificate, but they're going to switch to a CDSA in February. Actually, we need to be ready for that, Michael. But anyway, sure. So that's it's already there. I just didn't generate the circuit because that's a lot of combinations. I just need to press a button and hope my laptop doesn't crash, because a lot of now go compile at the same time. It's very challenging for my computer. But yeah, so essentially, this is depends on iOS, for example, the circuit is like still in the subgroup to the 2 to the 20, and on Android, most of them are 2 to the 21st because there's a lot of signature and hash. The most expensive part is really the hash, actually, like the SHA-256, SHA-384, and I didn't see any SHA-12, 512 yet, so should be alright. Wow, hello, sir.
And one other cool feature that you get on iPhone, which isn't on Android, is you get this, they call it true depth. And so you have this like infrared sensor that creates like a dot projection, they call it. So it's basically a bunch of infrared dots projected. So every time you unlock your phone on iPhone, it's basically like shining these dots on your face. And the distortion of the dots allows them to create a 3D model of your face, which is really cool. So it's literally like you can generate a 3D model. It's a kind of a form of LiDAR. So then when you enroll with Face ID on Apple, they are creating a 3D model of your face from these distortions of this dot projection. And that allows us, by tapping into that, it allows us to have depth detection, and you can't bypass it by, for example, just putting your passport up to the phone during the FaceMatch part of the flow. So that's not on Android though, at least not on all devices. And so to counteract that, protect against it, we have this liveness check where you have to like look to the left, look up, look right, and then we do pose estimation to figure out the direction the person's looking, that they are actually looking in those directions. And in a future version, we can do really interesting stuff, again, to get maximum support, because otherwise you're only going to be relying on iPhone. You want to also have Android supported. We'll have things like, for example, we haven't tested this yet, but we think it's a really cool concept, where you can have colors flash on the screen, and then we can have a look, like kind of like zooming in to the person's eye, and the reflection of the color in the person's eye would have to match the colors that were flashed. Like not too rapidly, in case like epileptics are trying to get through the flow. We don't want to induce any seizures. So maybe we should do some user testing to make sure that it's safe. And then the colors would be in a different order, for example. So that would be the challenge. And that all of this is to say that with generative AI getting better and better, the whole point is to defeat that, and the ability to like generate a generative AI video using like Grok or like VO, for example, or Gemini, because you couldn't do it in real time. I guess yet. As it gets more sophisticated, it's going to be more and more challenging. But I guess the more friction you add at this layer makes it more difficult for scammers. And they exist, they're out there. So we stumbled across recently, there was a screenshot someone sent through one of the groups of a KYC scammer selling like ZKPassport and UN Tech, essentially like verification services. This is before FaceMatch, private FaceMatch, so I think now they're going to have a more difficult time. But they had a spreadsheet of like all the services and all the customers and like the URL that you'd be scanning to perform the rest of the verification. And so initially for Aztec, for the sequences, we had the SIBA resistance where you'd have to essentially prove that you're holding a valid passport. The only thing that was being requested was this unique identifier. No other information was revealed, but that unique identifier is always going to be the same per passport or national ID. And so then that means that you don't have all these people airdrop farming sequences running all these different nodes, because it's basically one person, one sequencer. Or I guess more accurately, one passport, one sequencer. So, most people have one, maybe you have two. Less likely you have three, even less likely you have four. So it's and the government starts kind of raising their eyebrow, like, why do you have 10 passports? That's a way to have strong SIBA resistance still. And so what they would do is they would offer these services, and they would be having like a box full of, I guess, stolen passports, like at their place, and they get you to like send the QR code to them, for example, and they would continue the flow on their end to complete the registration. But now with private FaceMatch, obviously you have to be the person on the document. So unless they're like able to like a shapeshifter, they could morph into the different passport faces. That's going to be challenging for them. We've actually been meaning to do like undercover investigative journalism. We want to reach out to them and be like, yeah, please, I want a KYC, how much? And just get an idea of like how much it costs and if they can still do it, so we can provide measures to counteract it. That's next on the cards.
Yeah.
My feeling is that they're not going to be able to overcome this anytime soon. I know that I couldn't overcome it on iPhone. They're definitely not. There'd have to be like a 0 day that would be able to achieve this, to actually like properly jailbreak it without detection. On Android, I have a feeling I probably could if I spent enough time on it, but it would be very difficult.
Yeah, that depends on the device. Some devices have stronger guarantee than others.
So take Graphene OS, for example. That's a different, like, parallel version. We'll be adding not very soon, but it's on the roadmap. We want to add support for this, and that would be a different read certificate, I imagine.
I think it's still, I don't know if it's still Google's, but they definitely don't use play integrity.
Okay, yeah, and so then the idea here is that we would be able, like the service provider that's plugging in here, they can specify what they are considering acceptable. So they could choose only iPhone, only Android, I guess be more granular, depending on the requirements of their service, yeah. And also I can give a demo, I'll give like a screen share, if I can get it working, of how, I'll do an actual FaceMatch now. I'll do like a live one. So just give me a sec. But feel free to keep talking if you want to.
I'm just like...
Try not to dox myself too.
Wait.
I'll have to get to the right flow at the right time.
You just have to hide your details.
Sorry?
The mic is working. Okay, perfect.
Yeah, that's a good time for questions, I guess.
Questions. 2 questions, 2 short questions. First question.
Sorry, you only get one question per person.
Oh, what question? Okay,
unless you have 2 passports, then you can get another one.
then the most important question, can you maybe open, or more request, can you please open on the iOS App Store the app more globally? So I have an Android, Austria said it's working, I can download the app, but on iOS it don't let me download the app. And it's just a one setting, so just one flag for the European.
Wait.
Not sure I actually understand.
Yeah, on iOS, I can't download your app because my region is set to Austria.
Oh, and on iOS for iPhone?
Yes, and it doesn't allow me to download the app.
Oh, we haven't added it for Austria?
It should be for the entire world.
Should be globally.
Yeah, but you can test it.
No, I believe you.
Zero knowledge.
Yeah. And then it just works. I'm like, bro, what the hell?
But on Android I can do, but not on iOS. Yeah.
Chat with us after the workshop. We'd be happy to have a look. We can fix that for sure.
Did Apple just block country without telling us?
That's weird. Yeah. That shouldn't be the case. Thanks
but can I ask a technical question?
Of course.
Yeah, go ahead.
On the do you guys using actually the actual signature of the passport and like actually challenge the private key? and to get a response
Yeah,
back?
so yes, great question. The feature you're referring to is called active authentication.
Active authentication,
So
which is difficult.
It's just less supported. It's not difficult. We could definitely do it. It's just not on as many passports.
Yeah,
but we could add this as a feature for sure.
Yeah, that would be an optional feature because not all passport uses it. For example, my passport doesn't have it.
Okay.
So it would be very nice because you could derive like some kind of secret from that.
Yes.
But then the issue is like, if only 20% of passports support this, what are you going to do? Require that as a service? Or probably not, right? And then if you're not requiring it, then why even like bother using it? Because you want to let everyone in, even if they don't have active authentication. So you don't really, if you're still allowing people to get in without it, you're lowering it to the lowest security assumption, which is called passive authentication, which is essentially what I described before. It's the root certificate check all the way from the chain of trust, which happened as well for active auth, but with the difference is active authentication, that it performs passive authentication first, which is the check that it's a valid signed passport from an issuing government, but there's also a signature over this key pair, and then there's like a smart card on the passport itself with its own key pair. It can then sign things. So now you can have the passport sign like arbitrary payloads or a challenge request to add this extra feature. But again, not all passports support this.
Okay.
Yeah, that's the challenge.
Okay. Thank you.
No worries. Thanks.
My question would be, what kind of model are you using to do the face match? And can I run any arbitrary code inside the secure enclave? Maybe you mentioned it and I missed it.
I didn't catch your first question.
Like, what kind of AI model are you using to face match?
What kind of model?
Yeah, how are you like face matching?
Yeah, we're using, it's called ArcFace ResNet 100. It's a 170 megabyte model, a 512 dimension vector emerges. And so what that means is the model itself, when it's doing inference against like the matrix, which is the model, there are 512 different dimensions that it's checking against. I don't know them all, but it could be, for example, the ratio between like the eyes to the nose to the mouth. I don't know, the distance between the eyebrows and the eyes. But there's like 512 of these, and combined, these all make up the vector embedding, which is the face print that uniquely identifies. So it's like a fingerprint, but it's a face print, and that.
What's the name? I want to like save
the
it
model.
down.
It's called ArcFace, ARC, FACE.
ArcFace.
But
ResNet, ResNet.
Yeah, but we actually did the implementation in Rust. And so the Rust communicates with the Swift and the Kotlin to actually generate. There's a bunch of different languages in our stack. So there's Rust, TypeScript, C++, there is Noir, and just a bit of Python, but that's just for scripts. Yeah, it's a bit messy, but like you can. That's a nice thing. You can run like some native code, like Rust or C++, and just link it to whatever native language, like the OS, Swift, or Kotlin, and then you have the React Native upper layer in TypeScript. Yeah.
So my second question was like, can you run any code inside the secure enclave?
So the secure enclave is not an open-ended like TE like you would have in Intel TDX. So Apple or like the manufacturer of Android devices won't let you run arbitrary code. You can use that for cryptographic operations. So you can generate key pair, you can do signatures and all kind of stuff, cryptographic operations, but you can't run arbitrary code. What the actual secure enclave allows you to get, essentially sign a bunch of stuff, and you can attest, as Michael mentioned, to the key pair, and that's from a genuine device. But the app itself will be guaranteed by that way that it hasn't been tampered with. So the code logic is kind of like protected in a sense, even though it's not running in the TE itself in that way, like the secure enclave, I mean.
Then won't it be like manipulated by the client if it's not running inside the TE?
No, the point is that because it's attested, like the device is trustworthy and Apple attests to it, you know that that code cannot be tampered with. Otherwise, if that was the case, if that was a device that's not trustworthy and the code could be tampered with, Apple would not attest to it. Similarly, on Android, you have like the same mechanism, but the security assumptions may not be the same as on iOS.
It's not your classic TE, like an Intel TDX. It's that's why I call it like a mobile TE.
Yeah.
or called Attestations as the service.
Can you do this inside the browser?
No.
No, I don't think.
No.
Why not?
Well, there'd be a lot of outrage against that, I guess, because it's because in order to get this working, you'd need to have like a trusted computing set up, where from the bootloader it's onwards, you need to have the OS keep control, so you can't really root it. And so then for desktop computers, I don't think it's ideal, because you want to be able to root your desktop computer. For mobile devices, this is ideal, because it's not like a general purpose computer. But yeah, there's a trade-off here when it comes to like being able to own your own hardware and run your own code without the restrictions of like Apple.
So in a sense, like we're trusting Apple that it would only allow a trusted code to run.
Yeah, the trust
I just
in
want to
this,
make it clear.
Apple are
Yeah,
one of
yeah.
the parties of the trust here. Yeah,
Yeah.
you're trusting Apple to correctly respond by saying that yes, this is a genuine Apple device. Just like you're trusting Intel when they say that this is actually a genuine TE.
Yeah, I think it's going to become more and more common that within the ZK world, we're going to rely on like TEs at the edge, so like the edge devices. So essentially, you want to have some information that's been attested that you can use for proving. So like it's attested by some kind of signature, like any kind of sensors. Like it could be a camera, it could be like a thermometer, like any kind of like input from the outside world that you want to attest and use as a base to generate a proof, or like, and keep private. So you need some kind of way to testing to it, and like TEs are pretty good for that. On the other hand, using a TE on a server to have like privacy is not the same thing, and probably not the best thing.
Yeah, I think a lot of protocols are using this as like a cheat code, like a shortcut, in place of actual engineering effort to properly create like cryptographic guarantees in a protocol, and that should never happen at the protocol level. Only like as a layer above, as maybe on the application layer. And in this example, if you want to add private FaceMatch, because you're never going to get the complete guarantee that you get from ZK cryptography.
Yeah, my next question would have been, what if we run it inside the ZK VM, the FaceMatch?
ZK VM or ZKML?
ZK VM, because
Well, ZK VMs are not quite ready for mobile. There are some that are starting to work on mobile. Running an entire model on a ZK VM nowadays is probably not doable. But the thing here is that in any system where you attest to something, like cryptographic system, the system as a whole is as strong as your weakest link. Here, the weakest link is the camera, the device itself. You need to trust the camera feed. So you're already lowering your assumption to the device. So you may as well use that as the base.
Yeah, so let's say that you ran ZKML on this to get a cryptographic guarantee that whatever image you're running it over, the face print was derived exactly according to the logic of the circuit, which is very expensive, but let's assume that you could do it on mobile. There's no point, because the camera feed itself, the input, you could just fake the camera feed input, right? It's literally like a sensor that's just taking in a camera feed of a person. So because you're already lowering it to that, you may as well just do the whole thing from passport photo onwards with Attestations as the guarantee. You've already got the hardware level, that you're running, that you're not feeding in fake data as the lowest assumption.
Thank you very much.
Yeah, thank you. And so I can give a demo now of how private FaceMatch looks when using it.
Wait,
Oh, sorry, mate. Go ahead. I didn't see you there. Please.
I mean, you could probably. Oh, okay.
Can I give a demo and then we can continue? Because I'm really excited to show you guys.
Yeah, just give a demo and
Okay. And then we'll jump straight to you guys. And also, you can try this yourself right now. This is live in production. We haven't publicly announced and launched private FaceMatch yet. So normally it would be at demo.ZKPassport.id. But to be able to see it unlocked, you just have to put $FM equals 2 at the end.
Yeah, we just need to add. You just need to add this to the website.
We're gonna be making it it's a little secret cheat code. It's like please get a picture if you like the URL. And then so this is like choose your own adventure. You can try all these different types of proofs out for yourself. So in this one, I'm gonna go private FaceMatch. And so this is me. Yeah, this is like a live demo. So I'll select that. It'll provide a QR code.
Are you gonna dox yourself?
Yeah, I want to dox myself. So camera's down.
Is that a camera?
All right. So.
Yeah.
Oh, thank God! I enabled the feature that blurs my. That was a 50-50. So, okay, cool. Do a QR code scan. So everybody in the room, very nice, very nice. And then, all right, so we'll scan the QR code. This is a secure end-to-end encrypted WebSocket bridge, by the way. And then there's like a callback that gets sent to the website saying, yep, the user scanned it, so you can react to that and like show something else. This is asking whatever the credentials are being requested here. So this could be anything. In this case, it's just private FaceMatch. So then I'll go, yep, next. To my face. And this is the liveness check I was talking about. This is really fast now. It never used to be this fast, but thanks to a lot of the work from Noir over in the corner there, optimized the shit out of it. It's really good now. It's almost like too fast. People get confused. But that's it. And so now this is generating a zero knowledge proof locally, verifying all of the signatures from Apple's root certificate all the way through to the intermediate to the this credential certificate, which includes the public key pair. Then the key pair itself signing over the FaceMatch data. And then once that's done, that gets sent back to the service as a compressed proof. That can then either be verified on the back end. So you don't need to do blockchain. It could just be like a back end service for some kind of ZKKYC stuff. For example, with Devconnect, you didn't need a blockchain for this. So it just went to a back end service where it used the unique identifier to allocate a ticket discount code. Right? And then if you tried to like register again, well, it would just give you the same ticket code because obviously you're trying to like double dip with the discount codes. And there you go. And that's like private FaceMatch end to end how it works. So yeah, thanks. Oh, okay. Yeah, you had a question, please.
Yeah, let's take some questions.
Yes. So I was curious, what's the minimum hardware requirement on a phone in order to like generate that proof?
These proofs are pretty beefy, so like 32 gigabytes at least on a, no, I'm kidding. This actually used to be a requirement, but there's been so much optimization thanks to like Zach and others at Aztec, who, by the way, created Noir. This is all of our circuits are written in Noir. The backend prover is Barrettenberg. We've managed to get it down to like 1 gigabyte, which is like truly impressive. And this is only recently, by the way, like the last couple of months. I guess they were like deferring a lot of the optimizations until the very end. And so now even like lower end Androids are able to do this proving. And our actual design, we can talk about the design of the circuits. We have these 4 different sub-circuits to generate these 4 different sub-proofs. The first 3 deal with the signature verification from the root certificate to the intermediate and then over the passport data. And so we can actually cache those first 3. And the last one is the disclose proof. And that's basically like pivoting off the first 3 to be able to like do the private FaceMatch one or do like a disclosure of like which country you're from or which set of countries you're part of. And this design also means that given there's a myriad of different combinations of different signature algorithms from all the passports, we have like 600 circuits in total. And so you can kind of route through the combinations to create these, a unique combination of the sub-proofs specific to your passport. So actually, as soon as you scan your passport in, these first 3 sub-proofs start proving in the background because nothing else changes except the very disclosure part at the end. So then when you go to actually prove it, it's very quick. Only takes like a few seconds. And then finally, those 4 sub-proofs are recursed into a final outer proof. We call it like a compressed proof. And that's what's then able to go on-chain and is like EVM compatible. And for that one, because that's quite beefy, that used to be, so we have a cloud prover as a fallback. But because these 4 sub-proofs are already, sealed away, we can use the cloud prover to recurse it if needed. And so we try to do it locally first, but I think the requirements are like what?
So, yeah, the outer proof, so as we call it, the compressed proof, the sub-circuit size goes from 2 to the 22nd to 2 to the 28th. So this is beyond what mobile can do. So this is done on the cloud prover. So you recurse those sub-proofs that are already ZK and hit all the inputs. So the final one is just like adding some glaze onto it so you can have a single proof that you can verify on-chain. Because if you were to verify all those 4 sub-proofs on-chain, that would be a bit expensive in terms of gas. Yeah.
It's a nice background to show as we talk through the rest of it.
Yeah, that's the website.
Did you have a question, mate?
how is the accuracy of the model that you use compared to this runs locally, right?
This is what, so, yeah, all locally.
Yeah. How is that, how does that compare in terms of accuracy and false positives and stuff like that with the most advanced ones that probably run in a machine that is way more powerful and they probably take more variables or not at all, maybe?
Yeah, no, good question. So there's actually a mobile version of ArcFace ResNet, which is also a lot smaller. It's 10 megabytes something, but we decided to use the non-mobile version, which is 170 megabytes, because it's way more accurate, and it just works on mobile as well. So we figured we just go with that. And a lot of people, most people so far, have been able to get through. Although I have spoken to one person that said that they couldn't get through because they have a weird face or something. I don't know. I don't think that's. I don't know what the face looked pretty normal. It looked fine, I think. So maybe there's we're going to explore, speak with her a bit more and understand exactly what the issue is. The threshold is I believe it's 0.7. This is called the cosine similarity. So maybe we have to lower that, or actually maybe what we can do is have the service specify what their minimum threshold is, for example, right? To have a default that's sane, but then also allow you guys to plug in whatever you want.
Well, that could be the difference between the regular and the strict mode.
Right, so we have two variants right now. We have a regular mode or a strict mode. And then so the regular mode doesn't do a liveness check. The strict mode does. Because if I just put my passport photo in front of it, it would work because it doesn't know that it's not a photo.
No.
In fact, we probably just get rid of that because...
No. So the idea is to, as we start to strengthen the model, you want to have different grade of it because one maybe take more time. It will be half.
But you saw how quick that was, right? It's much faster now.
Yeah, I know, but you may want to have some more checks later on, but you can delegate the rest.
So we make what was strict, what was one strict, and make it regular.
Well,
it's an evolving protocol. And if you have any opinions, please let us know. We'll make it part of the protocol too.
Yeah.
Hey.
Are you planning to separate the because now you do, of course, the passport verification checks and all the certificates, and you have really the attestation level on the device. Are you planning to separate that attestation level on the device maybe as a separate library? Because I can see people would be very interested in leveraging the work you've been doing because you mentioned fitness devices, all of these kind of things, which might not immediately be useful for ZKPassport itself, but might be useful for other applications.
So that is something that we do plan once we get more time because we're pretty swamped right now. So the mobile app is, with the code source is for now still closed, but we do plan to pull out a big chunk of the modules like those and make it open source so you can actually use it. So you would have this app attestation service. You already have the part of the circuits public, so you can kind of guess, but you still need the implementation mobile to figure out how that works. It's not too difficult, but that should make it easier if we export it as a module you can use. I think there's other features we could probably export as module as well.
Yeah, there's some that make sense for ZKPassport. I think we'll add those, like the GPS coordinate one. Again, there's ways to obviously always thwart this. You could get a GPS spoofer and just have it next to your phone, and now you can be anywhere in the world. But it's increasing the barrier so that it's more this is all layers on top of the base cryptography that's ensured. And some other things could be, maybe a device ID that could be scoped by a service. So then the thinking here was that with the KYC scammers, they probably use the same phone for their 10,000, 100 passports that they scan in. This would be a way to have a device ID, and you get privacy through scoping it to a service again. So a service can only see the device ID relative to their service. If it's the same device ID for these hundreds of passports, maybe it's a scammer. And then you have to use Attestations on that to make sure that it actually is a device ID. Or maybe an encrypted IMEI number. But whatever we do, it would have to always preserve the privacy of the user. That's the core value here of what we're building. And also have consent, informed consent when you have the pop-up, right? They need to know what's happening, what's being shared, and they can either agree or they can disagree, reject it, Yeah, thank you.
This is maybe more of a product question than a technical one. One of the kind of criticisms I saw during the token sale for ZK Passport is like,
Criticism of the token sale. What do you? First I'm hearing this.
If you haven't heard, no, I'm not shilling here. No, so there's, I would say, folks that are just like, well, how do we know that only the ZK proof is being communicated at these over the wire here? Like, is there space for doing this in like an air-gapped scenario where there's verifiability of like what data is being transferred?
I mean, you could do this as a technical person. Have you heard of something called Wireshark? So if you run Wireshark, you will see.
This would be
Yeah. So if you run Wireshark on the network, you will see all the data that's transmitted on the network. So you'll be able to see what's actually shared by the app or whatever is on your network. So you're able to see if you have any passport data that's sent randomly, which this is not. But if you want to see it just for yourself, you can use that.
Yeah.
Wireshark is blocked by some networks, so do it at home. But yeah.
Yeah, and then you could basically install a custom root certificate on your iPhone, and then have that also in Wireshark, and then you'd be able to eavesdrop on all the traffic going through your iPhone, out of your iPhone, including ZKPassport, so you can see it for yourself. Yeah.
Cool. Any other questions?
So, if I want to build on top of your application, for example, is like some sort of a exchange, like half centralized, half decentralized, and I want to just use your solution, I still have to provide at one point to the authorities, yeah, this is my list of the customer. So this is like a no-go. So I'm just thinking of, is there like any way to, hey, like, there is still somewhere like a list, but it gets only open when this and this is like, or it just exposed like just like your last name or just like your first and last name. Is this like something?
Absolutely.
Okay.
What you could do for this, and this sounds like an off-chain use case, where you have like a back-end server, you just want to essentially like do a private KYC of your customers that you're not putting on chain. You could just request, for example, the first name and last name and maybe country, and this would be actually a really great way to have. I mean, the fields then could autocomplete. You wouldn't even need to arbitrarily type in your name details, because it would come from a government attested identity that attested over what your actual name and first name, last name is. So then it can pre-populate it. You can store it on the back end, and this kind of also opens up, I think, another really exciting area of a new kind of paradigm when it comes to like KYC that isn't this traditional, you send your photograph, your passport in, or they just look at it and go, yep, looks good, and they like reattest to it, and then they've got your data, is like a verifiable KYC. So for auditing for services, you have, let's say there's nothing's revealed, you just have like the sanctions checks and all these other checks that take place. You can also have that proof to provide the verifiability to the auditors that you did these checks at this time against these sanctions list. But for your use case, you can just literally like, you can have the verifiability that that's the customer's actual name, which is stronger than even having, getting a passport and making sure that it matches what they put in. And it's automatic. And like it's free because of what we provide. The infrastructure is there to tap into this. And you're not trusting us, you're trusting the government themselves. And then you're not revealing your whole passport data, just like you said, the first name, last name, country, date of birth, maybe if that was for your service. Yeah. Cool, thank you.
Assuming that's the last question, Theo and Michael would probably stick around for a bit as well, so feel free to catch them
come and
afterwards.
chat with us. We'd love to answer any other questions you've got.
Yeah, thank you, Michael. Thank you, Theo.
Do the melee.